Hello everyone, this is Ramji Sharma. Let's look at the average and instantaneous rate of change of a function. In this video, we'll be looking at the average rate of change, the instantaneous rate of change, and the slope of a function. Our first example has to do with the average rate of change. So the question says, find the average rate of change of f of x equals 2x minus 3 between x equals 1 and x equals 5. The formula for the average rate of change, so formula is f of b minus f of a over b minus a, where a is the initial point and b is the final point. So in our first example, we have a equals 1 and b equals 5. So we're going to find f of 5, which is going to be 2 times 5 minus 3, which is going to be 10 minus 3, which is going to be 7. Similarly, we're going to find f of 1, which is going to be 2 times 1 minus 3, which is going to be 2 minus 3, and that's going to be negative 1. Now we're going to put them all back into this formula, which gives us f of 5 minus f of 1 over 5 minus 1. That is equal to 7 minus negative 1 over 5 minus 1, which is a 4. And that gives us 7 minus of minus is a plus, so that's going to be 8 over 4, and 8 over 4 equals to 2. So the average rate of change of this function between the points x equals 1 and 5 equals 2. Let's look at another example here, which has a different function. F of x equals 2 minus 2 square root of x minus 1. As before, we're going to find the value of this function at 5 and 1. So let's find f of 5. I'm going to start with the second value first and the first value later, so we can put them back into the formula in the same sequence. So it's going to be 2 minus, so I'm finding the value of this function at 5, so 2 minus 2 times square root of 5 minus 1, which is going to be 2. Do not cancel 2 and 2 here, because that's not how you are going to do in this way. It's not allowed. So 2 minus 2 times the square root of 4, which is a 2, and that's going to be 2 minus 4, and that's going to be negative 2. So that's our f of b. Now let's find out the value at 1, which is going to be 2 minus 2 square root of 1 minus 1, and the quantity inside the radical is 0. That's why you have just 2. So the average rate of change is going to be, let's just call it ARC equals f of b, which is a negative 2, minus f of a, which is a 2, over b minus a, which is 5 minus 1, and that's a negative 4 over 4, which is going to be negative 1. So our answer is going to be negative 1. It's going to have to squeeze down here, so negative 1 is the answer. So in these two examples, as you see, we're just applying the formula f of b minus f of a over b minus a. So all you have to do is just identify the a and b as the first and the second point, and then plug these values into this function, evaluate the function, and simplify it to get the answer. Next, we're going to find the instantaneous rate of change of the function at a given value. The definition of the instantaneous rate of change is let's just write the definition here. The instantaneous rate of change of f of x at x equals a, and we have a notation for this, so we denote this by f prime of a equals is given by f prime of a equals limit h goes to 0 f of a plus h minus f of a over h, and this is called the derivative of f at a. So that's another name of the quantity here. So what it does is it gives you the instantaneous rate of change at x equals a. So you make a small change in the value of x from a to a plus h. H is a very small quantity, so you can go to the right or left of x and then find the difference of that new quantity from the original quantity, so that gives you the difference of the values, and divide that by the difference in the x values. So you're basically finding the difference in the y values and dividing that by the difference in the x values. So without the limit, it just gives you the average rate of change, but with the limit, when you make the change in the x value very, very small, infinitesimal small, meaning h goes to 0, in that case this ratio is going to give you the instantaneous rate of change, which means the derivative of the function. Alright, so let's look at this function given by 4x plus 3. So, and then the value of a equals 1. So we're going to do f prime of 1. That's going to be limit h goes to 0 f of 1 plus h minus f of 1 over h. I'm going to find out each value separately and then combine all the pieces together. So let's find out f of 1 plus h. That's f of x is 4x plus 3, so we're going to replace x by 1 plus h, and then copy the rest of the structure here. So 4 times 1 plus h plus 3. Now remember, in the definition, f of x equals 4x plus 3, this x is unknown, so it's just holding the place for some values to come in. So in our case, that value is going to be 1 plus x. So just understand that that x is just a placeholder for something. Okay, we can simplify this, so that's going to be 4 plus 4h plus 3. If I multiply 4 inside, that's going to give us 4h plus 4 plus 3 is a 7, so 4h plus 7. That's f of 1 plus h. Now let's find out the f of 1. F of 1 is the value of the function 4x plus 3 at 1, so just replace x by 1, and that's going to give me 4 plus 3, which is a 7. So I have a 7 for f of 1, and I have 4h plus 7 for f of 1 plus h. I mean, yeah, so the ratio with the limit altogether is going to be limit h goes to 0, and on the top I have the first value as 4 plus 4h. So let's just do 4h here. So hold on a second. 4h. So it's going to be where is the pen? Okay, 4h plus 7, that's f of 1 plus h minus f of 1, which is a negative 7, divided by h. Okay, so we're now back to the limit problem. So to find the limit of this type of rational functions, we have to be careful because there is a 0 in the denominator if you do the direct substitution. So the first thing you have to do is just simplify and factor out the common factors, all that type of thing. As you notice here, the 7 and 7 clearly cancel each other, so you have limit h goes to 0, and then it's going to be 4h over h. Now we can cancel the h's, so it's going to be limit h goes to 0, 4, and this 4 is independent of the limit value, so it's just going to be 4 because it's a constant, and that is the final answer. So the instantaneous rate of change of this function f of x equals 4x plus 3 at x equals 1 is going to be 4. Now later on we have a different formula to find the derivative of this function using the power rule and other rules, so that's gonna make this process much easier. It's just gonna be one line answer, but for now we're using the definition, so it's gonna take a lot of steps to get there. One more thing, this is a linear function, so it's not very interesting, but it's just a demo problem here. But the meaning is important. So there are three meanings of the instantaneous rate of change. So the first meaning is it gives you the change ratio, which means the rate of change when you change the x value by a very small quantity. The second thing you can think of this as geometrically speaking, this is going to give you the slope of the tangent. So if you are a pure mathematician or going to study pure mathematics, then you will be interested more in that direction. In the business point of view, this is going to give you the rate of change, or something called the marginal rate of change of something. For example, if it is a revenue function, then it's the instantaneous rate of change is going to give you the marginal revenue. If it is a profit function, that's going to give you the marginal profit, and if it is a cost function, then this instantaneous rate of change is going to give you the marginal cost. So that's why we're studying this thing in business calculus. Next, we have a little more complicated function. So if you want, you can pause this video here and work on this problem. Alright, back to this problem here. So we have f of x equals x squared plus 3, and we're finding the instantaneous rate of change at x equals 1. So the formula is f prime of 1 equals limit h goes to 0 f of 1 plus h minus f of 1 over h. And now we're going to find these values separately for each function, f of 1 plus h and f of 1. So let's find that. So f of 1 plus h is gonna be, so we have f of 1 plus h, that's gonna be the value of the function evaluated at 1 plus h. So that's gonna be 1 plus h squared plus 3, and let's see how much it is. So that's square of a binomial, so we just have to FOIL it or use the formula. I'm going to use the formula of a plus b squared, so that's going to be 1 plus 2h plus h squared plus 3. So if you don't know how to get from here to here, you might want to just FOIL them all together. So 1 plus h, 1 plus h, and then just 1 plus 1h, which is h, plus another 1h, which is h, plus h squared, and that's going to be 1 plus 2h plus h squared. So that kind of thing should be doable, and you should not spend much time on this one while working on this one. So if you're not familiar with this thing, you might want to go back and review the videos where I talk about these types of things. And so this one is, after simplifying, it's going to become h squared plus 2h plus 3 plus 1 is 4. Now let's look at f of 1. So f of 1 is going to be 1 squared plus 3, because we're replacing x by 1, so that's going to be 1 plus 3, which is going to be 4. Now finally we're going to put these all together into this big formula, so it's going to be limit h goes to 0, and then you have h squared plus 2h plus 4 minus 4 over h, because this much is coming from here and the 4 is f of 1. So now we have to simplify it, so 4 and negative 4 cancel before we apply the limit. So limit h goes to 0, h squared plus 2h over h. Again, this problem now boils down to finding the limit of this function. While finding the limit, the first thing we do is try the direct substitution, but the direct substitution produces 0 in the denominator, so you have to factor out the h from the top and the bottom. So if you do that, that's going to be limit h goes to 0 and then factor of h outside, so it's going to be h plus 2 divided by h, and you can cancel that, so that's going to be limit h goes to 0, h plus 2, and now you can apply the direct substitution method, because this is just a polynomial, so it's going to be 0 plus 2 after you apply the limit, and that's going to be 2 as your instantaneous rate of change. Alright, so this is a little bit more involved and a little more labor intensive problem because of the square term involved in it. In the previous example we just had a linear problem, so we didn't have to work on the algebra side that much, but this one definitely requires a lot of work. Now again, this is not always possible to do this much amount of work to find the instantaneous rate of change, which is also the derivative of this function. We have rules, something called the power rule, and that gives you the answer in 2 lines. But for now, we haven't talked about that yet, so we just have to rely on this one. Next, we have to find the solution of an application problem. So the instantaneous rate of change is going to give you the slope of the tangent. Also, that's going to give you the marginal cost and marginal revenue. I'm going to do the slope problem here in this example. So the problem says find the slope of the tangent to the function f of x equals 4x plus 3 at x equals 1. So the slope of the tangent is f prime of 1 is the slope of the tangent to f of x at x equals 1. But we already found this f prime of 1 in our previous example. Let me take you back here. So f of x equals 4x plus 3 at x equals 1. So I think it's the same problem. So f of x equals 4x plus 3 at x equals 1. So we already found the answer to this one. So our answer was 4. So from our previous example, f prime of 1 was found to be 4. Therefore, the slope of the tangent equals 4. That's the answer on this one. Alright, so that is all I have for the average and instantaneous rate of change. I hope you enjoyed watching this video. Thank you for watching. Bye-bye.